after a fade out. I had to actually look at the clock. So we got to wrap up last time's slides, Monday slides. We got to abstract and didn't really get to talk about it at all. So let's talk about abstract to start. Before we get into it, anyone got any questions off the top? Let's do it. Abstract. So abstract. We can have something called abstract methods. If we want an abstract method, we use the keyword abstract, and then we'll define we'll declare the signature of a method, which is its return type, its name, and its parameter list, including types. And then we just cap it off with a semicolon. No body to this method. This is called an abstract method. And the big thing about abstract methods that you need to know is they can't be called, ever. This method has no definition. There's no body to this method. So if this method were called, what should it do? I don't know what it should do. We could take guesses. We could just make something up. We could say, well, this method returns void, so maybe we just have it not do anything. Might be a reasonable guess, like a reasonable thing for it to do. What happens when it has a return type, especially? Maybe we could return the default type if it returns a default value. If it returns an int, we have it return 0. If it returns a reference, have it return null. Maybe we could do all that and have a good answer to this question. Java says no. We're not doing any of that. Java has a lot of protections in place that says you can never call an abstract method or your code will not compile. I will not run your code if there's even a chance that you're calling an abstract method. So we cannot call an abstract method in Java, even if it does return void, even the simplest answer as to what it should do, cannot call an abstract method. They cannot be called because they have no definition. There's no body. What code executes? I don't know. Java doesn't know. Can't do it. If a class has at least one abstract method, if it has any abstract methods at all, the class itself must be abstract. So we have an abstract class is a class, let me say it the other way around. If a would-be class has any abstract methods at all, it must be an abstract class. Bless you. Java will not give you another option. It has to be an abstract class here. If you have a class, bless you, that has any abstract methods. An abstract class cannot be instantiated, meaning you cannot create objects of an abstract type directly, at least. You cannot say new game item to try to create an object of type game item. Not allowed because game item is abstract. And game item has to be abstract in this case because the use method is abstract. Must be abstract. Cannot say new game item. Can't happen. Because if you could create a new game item, if you could say new game item in your code, you might be tempted to call this abstract method, which Java doesn't allow. So Java's not even going to let you get into a situation where you can call an abstract method. So you cannot create objects of abstract types. These abstract methods exist only to be inherited and overridden. It's the only reason they exist at all. The only reason abstract classes exist in general is to be extended. We're going to inherit these abstract classes. And then in the abstract class, that's where we're going to implement these abstract methods. So if you extend an abstract class, if you inherit from an abstract class, you're going to inherit its abstract methods, in this case, method. You're going to inherit this method that has no definition, and it's your responsibility in that class. It's that class's responsibility to give a definition to this method. You're going to have to override. You're not technically overriding anything because there's nothing to override. There's no definition. But we still call it overriding. We'll still use the keyword, the annotation override. But your responsibility is to override this method to give it an implementation, give it a definition, give it a body. So there is code defined that's going to be executed when that method runs. That's the responsibility of any class that's inheriting from an abstract method. Must implement all from an abstract class. Must implement all abstract methods, unless you don't want to. It's kind of optional. If you don't implement every single abstract method that you inherit, that's actually fine. Java will let you do that. Will let you skirt that responsibility. as long as that method, that class also is abstract. So if you skirt this responsibility, you don't implement every abstract method, then that class also has to be abstract because it has at least one abstract method. And this is something we might actually do. That is an actual common thing. We have the weapon class. If we have the game item class, which is abstract. If we want the weapon class to extend the game item class and not implement use, that might be something that we do and add any weapon-specific behavior to it. And then we might want a bow and arrow class that extends weapon. And then the bow and arrow class will actually implement all of the undefined behavior, all of the abstract methods. So that is a common thing to do. Common thing that we do in practice is we'll have abstract classes, extend abstract classes, and then have finally, at the bottom of the inheritance chain, have some what we call concrete classes, which is any class that's not abstract. We have concrete classes that finally implement the abstract methods that it has. So if a class extends an abstract class and does not implement all of the abstract methods, it too must be abstract. Why would we ever do this? Why would we ever want an abstract method? This is a silly thing to do, right? If we have a method with no definition, why don't we just not do that? We could just not do it and be just as well off, right? And then in any class that does extend game item, just define the use method in those classes. Like we're going to anyway with the abstract class, abstract method, we have to implement this method in all those classes that extend it. So why even bother with this part? Why don't we just implement this method in all the extending classes and forget the whole abstract class, abstract method thing? And life would be just like it was 10 minutes ago, where you don't even think of this stuff, don't even know it exists, and you were plenty happy 10 minutes ago, I presume. So why would we ever do this? And it's because of that big downside of polymorphism. So polymorphism says you can only call the methods known to the type of the variable, and I was always very careful to say known to, not implemented in, because this method isn't implemented in, but known to the type of the variable. So if I have a weapon or a health potion stored in a variable of type game item, I can only call the methods, bless you, known to the game item class, and the abstract method gives me a way to say this method is now known to the game item class. There's that, but then why don't we give this some definition too? Like we did when we first saw the use method, we had its implementation in the game item class was system.out.println item used, something like that, some useless like that. So abstract method is useful when there's no useful, it's useful when there is no useful default behavior. I don't have any default behavior here that makes sense when any game item is used. I want every single actual game item type to tell me how it's used, what happens when this item is used, because I'm going to have a wide variety of different items. Weapons and health potions are very different things. They're going to do very different things when it's used, so I don't have any default behavior here that makes sense. So I'm going to make it abstract to say every object of type game item, everything that extends me, has to have this method, so I can call this method through variables of type game item, but I don't have any meaningful default behavior that I want to give to every extending class. I'm just going to give every extending class the responsibility to implement this method. So it's kind of a specific set of circumstances that makes this useful, but that set of circumstances, as it turns out, comes up a lot in programming. We want to call this method through variables of the supertype, but we don't have any good default behavior to give every value, every object of that type. That's when we use abstract methods. And once we start using abstract methods, we, by default, have to start using abstract classes. Yep.
So if I create an object that inherits from game item, how does calling the super constructor work? Like, if you can't create an object that's like game item, then how do you call the super?
Yeah, so it's a little more nuanced. You can't create objects of type game item directly. So I can't say new game item, but if I say new health potion, the superclass constructor is still called. So this constructor will still be called when the child types are instantiated. I just can't call this directly, because then this won't have a definition. But when I create a new health potion will implement this use method. So it'll be a concrete class that'll have all the abstract methods implemented, and then the superclass constructor is called. Good question. Yep.
I'm not sure if I missed something, but like, do you have non-abstract method in an abstract class?
Yes. This came up in the other lecture too. I wish I updated the example. But we can have additional methods here that are not abstract. I could have 100 defined methods and then one abstract method, then my class would have to be abstract. Can multiple classes inherit the same abstract class? Oh yeah, of course. A health potion and weapon both extend game item. Can multiple classes inherit the same abstract class? Yeah. And just make sure I'm reading that right. And if that is possible, can two different classes that inherit the same abstract class have different uses for the same abstract method? Yep. That's exactly what we're doing here, is both health potion and, because we had this code before, way back in Inheritance Week, it was a while ago, but we had the same code, but this was not abstract, and it had a default behavior, and then health potion and weapon would override it with different definitions. And when we get to the memory diagram, we'll see that it'll be set up a little bit different, but health potion and game item are both going to override the abstract method with different definitions. And then which method is called is going to depend on the type of the object on the heap. So the type of the object is going to determine which of those definitions will get called. What can't happen is having one class extend multiple abstract classes or concrete classes. Extending an abstract class or a concrete class behaves the same way, except you might have that additional contract to implement the abstract methods. But you can't extend multiple classes from one class. That's one thing that's not allowed. And I'll talk about that more when we get to the next slide, actually. Yep.
So if an abstract class is extending some other class, will its method be overridden with the abstract method if they have the same name?
Oh, yeah, that's a good question. I don't think so. I think it would just keep the definition untouched, but I'm not 100% sure on that. So the question is, if I have some other class that has a concrete method, void use, takes a player, has a definition, has some implementation, and then game item extends that class, would that definition be overridden to be abstract now? I actually don't know the answer. You know what? I could go 50-50 on that. Would it override it and make it abstract, or just inherit that definition? I'm not sure. I want to try that one now. Maybe we'll try it Friday's live coding. Maybe we'll try it when we get live coding. And with abstract classes, I say, I was careful with the way I word this. If you have any abstract methods, your class must be abstract, but that's not an if and only if condition. If I have 0 abstract methods in my class, I can still make my class abstract. You can just decide to make a class abstract whenever you want, even if it has no abstract methods at all, which is a fairly common thing. I like to do that quite often in my code. What that does is gives you the protection to say nobody can instantiate this class directly. In this case, even if I had good default behavior for the use method and I didn't want any abstract methods, I would still make game item abstract because I don't want to accidentally create an object of type game item. When I have my game, everything's built out, players are having fun. I don't want to somehow, somewhere in my game world, have an item of type game item because that doesn't make sense for me to have. I need a specific item. It should be a weapon, a health potion, a bow and arrow, a bomb. It should be an actual thing. If I have a game item of type game item, it's going to get only all of the default behavior from this class, and it's probably going to behave quite strange in the game. I probably won't have any art assets for it, so it's going to look like a broken image, a broken model or something. It's going to look really bad. So I'm just going to label it abstract and say nobody can create a game item, just to make sure I don't accidentally do that at any point. You can only extend one class, which is a pretty big limitation. The danger here is that if we abstract two classes and they both have methods with the same signature and neither of them are abstract, they both have definitions, I'm going to get the same method with the same name, same parameter list, same return type. I get this method with two different definitions. I get this definition from this class, this definition from this class, and then from this type that's extending both of them, I call that method. Which definition is used? I don't know. I don't know. Java doesn't know. And Java says, you know what? I'm never going to let you get in that position. By the way, Java does this a lot. It'll stop us from getting in our own way quite often, almost to a fault. Depends on who you ask. They'll say it's to a fault or not. But Java won't even let you get in this position. That's why you can only extend one class, is to avoid this situation. This is called, if you want to search it up, it's called the diamond of death. A problem of inheritance where you have two classes extending presumably object, and then one class extending both of those. Other languages like C++ will let you do this. C and C++ in general do not prevent you from getting in your own way at all. Those languages will let you do whatever you tell it to do, even if it's completely broken or undefined behavior. So if you have the diamond of death in C++ and you call the method, it's up to pretty much chance as to which method is going to be called. But one of them will be called. Like something will happen. It will let you get in that situation. It's going to be up to whatever compiler you use, whatever system you're running on. A lot of things are going to decide. Not decide, but just happen to whatever one ends up getting called. Java doesn't let you get in a similar situation, so you can only extend one class or abstract class. Completely prevents that. Bit overkill, but completely prevents that. If we do want to extend, or I shouldn't say extends, but if we want to inherit from multiple classes, we can kind of do that by using something called interfaces. So interfaces are like classes. We're going to replace the word class with interface. This is our third flavor of top-level structure in Java. Is an interface which is like a class, but it can only have abstract methods. That's it. Abstract methods. It's the only thing it can have. That means no instance variables, no constructor. So no constructor at all, not even the default constructor. So when something implements an interface, there is no superclass constructor call for that. It does not even exist. There is no constructor. And no methods with definitions. All the methods have to be abstract. And then if we want to inherit from an interface, we're going to use the keyword implements instead of extends. And we can implement as many interfaces as we want. Since all of the methods are abstract, we do not have the situation where we have multiple definitions for the same method. It can't happen because the methods are all abstract. So we can extend one class. That class might have a definition for a method, and then we can implement two different interfaces. Maybe this interface says you have to implement this method because I have it as an abstract method. This interface says you have to implement this method. And I extend an abstract class which says, here's a method, all of the same name. Here's this method, it has this definition. I have the contract twice that says you have to implement this method, and I have a definition for that method. But there's only one actual definition, so I'm fine. I didn't get in trouble with that one. If 10 different interfaces that I implement all tell me I have to implement the same method, I still just have to implement that method. There's no conflict here. There's no diamond in death. So if they're only abstract methods, we don't have the same issue, and we can implement as many interfaces as we want. And I don't have an example of it, but the syntax would be a comma-separated list. I would put comma and then another interface name if I want to implement multiple interfaces. So we can extend one class and also implement any number of interfaces. Yeah. Oh, don't know if it has to. I always do. I don't know if it has to. I assume it does. Yeah.
I see that it doesn't have a scope keyword for a abstract.
Scope key. Oh, right here.
The only term element in the name.
Yep. Interface, abstract method. I think abstract methods in general must be public. So if I do write the keyword public right here, if I do that in IntelliJ, IntelliJ will have it grayed out, and there will be a warning that says, why did you even put this here? It doesn't need to be here. And it'll suggest that you remove it. That's the extent of having it be optional. It's technically optional. You can have it there. I usually like to be explicit about everything, but this is one case where it has to be public, so I don't bother. Yeah. Yep. Yeah, and for the memory diagram today, we're going to do exactly that. We're going to extend and implement in the same class. Why would you do this? Oh, well, I kind of already answered it. But you can implement as many interfaces as you want. That's abstract methods, abstract classes, and interfaces. Any questions on any of that? We got one in chat. What is the syntax for implements multiple? Oh, yeah, I did answer that one. It would be, in your example, it would be public class X implements Y, comma, Z. Okay. Any questions? Yeah, Dominion's got it. Demian. Demine. I saw an extra N in there. A few extra letters in there. Yeah. Thanks. All right. Everyone knows what polymorphism is, right? When we have an object of one type stored in a variable of a different type, that's when we're using polymorphism. Before that, if that's not happening in your code, you're not taking advantage of polymorphism in your code. That means extends, implements, abstract classes, interfaces, all of this stuff. Everything, it's all inheritance. And this is the line between inheritance and polymorphism. Once you have an object of one type stored in a variable of one of its supertypes, specifically, that's when you're using polymorphism. That's when it's polymorphism. And the lines, I'll blur the line a little bit here. Abstract classes, abstract methods, and interfaces don't really make sense unless you're using polymorphism. If you're not using polymorphism, you could just let all of your classes define their own methods. You wouldn't need that abstract method defined anywhere else if you're not storing objects of one type and variables of another, because the only reason to have an abstract method is to be able to call that method from a variable that mismatches with the type of the object stored at that variable. So that's why we hold off that conversation until polymorphism week. So those are, I don't know, debatable that those are part of polymorphism or inheritance. But inheritance versus polymorphism, you'll probably get asked this on the interview in 2-3 weeks, depending if you count the break week or not. What's the difference between polymorphism and inheritance? This is polymorphism. All the other stuff is inheritance. Inheritance would be like extends, overrides, all that good stuff. When you grab all the state and behavior from another class and jam it in a class, that's inheritance. Polymorphism is when you're doing this. And here's our memory diagram code. This one's, logistically, this memory diagram set up a little different just because I have to use so much dang code for this one to set up extends and implements in the same object. Extending an abstract class doesn't make sense. It's not useful unless I'm extending it with at least 2 other classes. If I have game item and only extend it once with one class, why did I even bother with inheritance? I would just put everything in that one class. So just to get everything that I want in one memory diagram, it has to take quite a bit of code. I want a class that takes advantage of the polymorphism by having an array list, methods that take the interface type and a data structure to the interface type. So there's a lot of code. So I'm going to do some hot swapping of code. This is the only slide where we'll get to see all of the code in one place. And then when we get to the memory diagram, the whole right-hand side is going to be the memory diagram. So I'll swap in the relevant code for each slide. So let's look at the whole program while we have a chance to see everything all at one time. We'll go through the thing. We start at main, create a player class, create a weapon and a health potion. Through here, the biggest thing that I'm going to say, I'm going to get back to my reminders of call the superclass constructor. We're going to call the superclass constructor when weapon and potion are created. And the superclass constructor is only going to be the class that it extends, not any of the interfaces. Interfaces do not have constructors. There's nothing to call. There's no superclass concerns for constructors with the interfaces, only the class that it extends, class or abstract class that it extends. Then we're going to pick up that weapon and potion. Pickup takes a usable and adds it to this inventory, this array list of usables. That's perfectly fine because weapon and potion both implement usable. So these are all valid calls. We can assign a reference to a potion and a variable type usable. Weapon and potion, these can both go into a method that takes a usable and an array list that takes a usable, all through polymorphism. And then use all items, the big method here. We're going to iterate over our inventory and use every item in the inventory, calling this item.use method. And the question is, which method is called when the use method is called? With this example, I mean, I still get to explain everything, but it's not too hard because if you ever find yourself in this interface trying to call this method, well, it's abstract. You can't call it. So you know you took a wrong turn somewhere, and then you can back up and figure out where you went wrong. But this use method is going to depend on the type of the object that called it. So even though item is of type usable, the variable type only determines if this is a valid method call. The object type actually being referred to is going to determine which use method is being called, whether it's a weapon or a potion. Bless you. So that's everything we're looking at in this memory diagram. So the two big things here, don't forget then the two big things for the quiz next week. Don't forget your superclass constructor calls and which method is being called. It depends on the type of the object, not the type of the variable. Those are the two big things we're assessing. The questions will be custom tailored to hit those 2 points. Those are the ones that we want to talk about. And of course the polymorphism stuff, but really, if I'm being honest, it's the inheritance quiz. It's not much about polymorphism for reasons that I'll talk about. But let's get the memory diagram up there first. Actually, let me talk about it on this slide. I'll talk about it again when we get there in the memory diagram. But polymorphism, it's a very powerful thing when you're designing your code and applying polymorphism. Very, very powerful tool. But it's all about types of variables, types of objects, and everything. And it determines whether or not your code can compile. And I know I said this Monday too, but I'm going to say it again. It determines whether or not your code can compile. But the code we give you on the quiz is going to compile. You can just assume that we got all the polymorphism stuff right because we gave you the code on the quiz. And the answer isn't going to be this doesn't compile. So you can assume that all the types are going to match up the way polymorphism expects them to be. So if you go into the quiz just thinking inheritance, just thinking the stuff that we learned in inheritance week, you'd be perfectly fine. If you just ignore all the polymorphism stuff. On the quiz, of course, on the interview and task 7, that's where you're going to have to do polymorphism and actually understand how it works. But on the quiz itself, you can assume everything compiles. You'll be fine. And I told the other section, so I better tell you all too. I won't put interfaces on the quiz. Just because I said so many times, and I'll say a few more times today, don't forget your superclass constructor calls. Your superclass constructor calls are always called, all that. It gets a little confusing with interfaces. You have to remember that this is not called, but this is called, the constructors. So I just won't put interfaces on the thing. But I will talk about interfaces in this memory diagram, of course. Yep.
Oh, what about
I will 100% put abstract classes on a quiz. Yep. You can count on that being there. But like I won't try to instantiate an abstract class, so like you can just treat it as a regular class. Like it won't ultimately make a difference in the way you approach the quiz. Okay, let's start this thing. So we'll create the player class. There's only one new wrinkle in here, but we also haven't done OOP in quite a while. We spent quite a bit of time in data structures and testing. So let's review some of this. We're going to call the player constructor. The player constructor does not exist in this code. There's no explicit constructor, meaning that the player class gets the default constructor, which is a constructor that takes no parameters and doesn't do anything. So we still have, even with the default constructor, we still have the keyword this, which is going to be a reference to the object that's being created, and then that's the reference that's returned and stored in the player variable. The one wrinkle here is that the lines that create the instance variables are all called, and one of these lines does call a constructor, does create a new object, this new array list. So this code still executes, even though the constructor itself doesn't do anything. Through declaring and assigning the instance variables, I do have some extra code, an extra method call that's being called. Now this method call is internal to Java, so we don't care about it on the stack, but we do have to be aware that there is an array list created on the heap, and that inventory is going to have a reference to that array list on the heap. This is also something I probably wouldn't do on a quiz. I mean, it'd be a valid thing to put on the quiz, but I only did it here to save a few lines of code. I didn't want to add the constructor. I'm already really strapped for space on this memory diagram on the slide, so I wanted to do everything inline if possible. But that array list is created when the player constructor is called, even though the constructor itself does nothing. All right, then weapon and potion are created. Don't forget your superclass constructor calls. Whenever you see extends, there is a superclass constructor called, period, all the time, 100% of the time. It's called. It will be called. In this example, it's explicitly called. When I call, let's start with weapon since it's the first one here. When I call the weapon constructor, of course, is called. The first line here is an explicit call to the superclass constructor, which in this case must be there because the superclass constructor takes a parameter. If the superclass constructor takes any parameters, then it must explicitly be called. If the superclass constructor does not take any parameters, then I could put super, open paren, close paren, semicolon, that'd be fine. Or I could just leave it off, and Java will implicitly add it for me and call the superclass constructor. But the superclass constructor is 100% of the time called when you see this extends. So we have both constructor calls here. Yeah.
It's not there, and the superclass constructor doesn't take any parameters. You still have to make
You still make that stack frame, yep. And this is always a reference to the object that's being created. So we're creating one object through two constructors. Both constructors, this is a reference to the object being created. So even if this weren't here and this weren't here, that superclass constructor is still called, but that would be an implicit call to the implicit super constructor in game item. But the superclass constructor is always called. Always called, yeah.
In the inheritance chain, if there's like a series of classes which do not have any constructors and they are only their default constructor, will it be called explicitly? So I would have to call only a constructor with name of the class and this, or will it be just a default constructor? I just skip it.
It would still be called implicitly. So if we have a chain of inheritance, the question is if we have a chain of inheritance, a class extends a class, extends a class, extends a class, extends a class, all of the constructors are called in that entire chain. If that chain is 100 long, they're all called. Even if, like in the middle, there's like 50 of them in a row that all have the default constructor, don't have any explicit constructor, they're still all called, and you would put them all on the stack with just this. This and a reference to that object being created, and you'd have a whole bunch of those right in a row. And there is technically in this example, there's two more constructor calls. Game item doesn't extend anything explicitly, so we'll implicitly extend object. So there is technically game item and then the object constructor right here and the object constructor right here, internal to Java, so we don't trace it. But there is a third constructor call for each of these objects. There's 6 total constructor calls, well, 7, 8, including player, and player would call the object constructor. So there's quite a few constructor calls in this code, even though we only created 3 objects. It's a lot of constructor calls going on. Don't forget your superclass constructors. If anybody, I'm hoping we can get to 100% on this, that nobody will make that mistake. Nobody's going to forget their superclass constructors next week on the quiz. I'm hoping, or else, because I've said this, I don't know, maybe 50 times, maybe not quite that many, but a lot of times in lecture. And if a good number of students miss that in the quiz next week, I'm in a dilemma, because like, do I go up to 100 times next semester? I don't know how many times I say it. Maybe I just need a new approach other than repetition, but call your superclass constructors. Nobody's going to forget. What's up? Try saying it in lab. Oh, really loud. Call it. I don't like being too loud. Maybe if I turn the mic off. Yo. I could. Paul likes doing that stuff. I'm hesitant to do that. I'm always afraid nobody's going to repeat it. I'll look like a dumbass. But Paul likes doing that stuff, and he has fun with it. But I can't do it. What's up? So there's no object of type game item. We're creating an object of type weapon, an object of type potion, but those objects call their superclass constructors. But these constructors are only called through potion and game item, or potion and weapon. And your kind of rule of thumb to remember this is when the superclass constructor is called, we don't have the keyword new. So we're not creating a new object. We're calling the superclass constructor without creating a new object. If I forget my this, will I be shamed? If you forget it in every single stack frame, you might be shamed. If you forget it in a few, like I see students miss this in like a couple stack frames, but they have it in most of them, that's easy to overlook. But if you miss it every single time, then I know you don't know what's going on in the code. Yep.
If you call something like game item weapon equals new weapon, put the thing on the heap weapon of the item.
On the heap, so polymorphism does not change what goes on in the heap at all. It would still be a weapon. So if I did game item thing equals weapon right here, I'll get a new variable on the stack thing with the reference OX480, but no change would happen on the heap at all. Yep.
Use the super block. If you didn't have that, I know it's still called, but like it still has the value of blocking, but it's not called.
So in this case, we do need to have this for exactly that question. If we didn't have this explicitly, because the superclass constructor does take a parameter, we have to have this be explicit because Java's not going to just assume that we wanted to pass lock into it. So we do have to have this. If the superclass constructor doesn't take any parameters, that's when this is optional. Because if it doesn't take any parameters, we're not making any decisions and it has to be called. So Java's like, I got you. I know what you have to do there. But if there's any parameters, Java's not going to assume what we want to pass. Because we might want to pass some default value like 0.0 here or 10 or whatever. It's not going to assume, well, you do have a variable in the stack frame that's of the same type that the superclass, it's not going to do any of that for us. Yeah. I might have to tell all the TAs to do that. If somebody walks in, if somebody misses a superclass constructor call, every lab for the rest of the semester, everybody has to shout when you walk in the lab, there's the guy who forgot the superclass constructor call. That might work. How would people know? The TAs can tell. That's the one reason we would violate FERPA is for that specific reason. Yes, I would leak the classified files just for that specific thing. It's the only way I would risk the federal government being on me is for that exactly. I forgot this. What's up?
Maybe you should remind us every time we open our notes.
About the superclass constructor? I feel like I do. At least during inheritance week and polymorphism week. I feel like I do. But I can some more. Don't forget your superclass constructor calls. Ever. Don't forget. So many gushes. All right. So weapon is stored in this weapon object is stored in a variable of type weapon. So we have access to all the weapon specific stuff, everything a weapon can do. Potion was stored in a variable of type usable. So from this potion variable, we can only do things that we can do with any usable, which is call the use method or pass it to a method that takes a usable. That's really all we can do. Maybe put it in a data structure of type usable. But we are limited. We can't access health potion specific stuff from potion because of the variable type. Again, this is something you would never do necessarily. You would store this in a variable type potion, except in lecture I want to show that that's a thing you can do, so that's why I'm doing it here. You'd never actually do that in code unless you have a really good reason to. There's really no reason to do that. But it is allowed. We can do this. We're allowed to do this. Doesn't mean we should. And then we're going to call the pickup method on both of these items. Weapon is a variable of type weapon, but the weapon class, not on screen, it implements the usable interface, so it is a usable. So this is valid. Pickup takes a usable. We gave it a weapon. That's a valid call because weapon implements usable. Potion, that variable is of type usable, so our polymorphism check is on this line. Again, polymorphism is checking, does this code compile? This line compiles because potion implements the usable interface, so this is a valid assignment. And then we give potion of type usable to a method that takes a usable. That, of course, is valid because it's the same type. And then we're taking both of those references and storing them in an array list of type usable. That's, of course, fine because item is of type usable. Now, it happens to be a weapon and a potion that makes it into this array list. But since they both implement usable, that's all valid code. In this pickup stack frame, in fact, pickup and the player class overall doesn't care that that's a weapon and a potion. Doesn't even know that it's a weapon and a potion. There's no indication at all in this code that there's weapons and potions. We're just coded to the interface, coded to the usable interface, and everything works the way we expect it to because we gave it objects of types that implement the usable interface. And then polymorphism said, yep, that's cool. We're allowed to do that. So this is the big power of polymorphism. We have a method that's coded to an interface type or an abstract type would be fine. An abstract class would be fine too. But we're coded to an interface. So this one method can handle anything that implements the usable interface, even classes that don't even exist yet. As I start adding more and more features to the game, this one method is going to be able to handle them as long as all those new game items implement the usable interface. So anything that can be used by a player, I'm going to implement the usable interface in those classes, and then the player can use those things and store them in their inventory of type usable. The other side of polymorphism, data structures. We have a data structure coded to an interface type, and it can store any object that implements that interface. These are two big things, methods that take that type and data structures that take that type. And this is where we do see the assignment. I keep saying you would never do this inside one stack frame, but we do the same exact thing in the next line. We do weapon, which is a variable of type weapon, usable item equals weapon. We are assigning across stack frames, and that's where polymorphism gets useful because we can write this one method that works with multiple types, and the assignments of parameters to arguments is allowed through polymorphism as long as the argument extends the parameter type. That's where polymorphism is useful. Never within a stack frame, or I shouldn't say never, but 99% of the time not within a stack frame, but when it's across stack frames or when it's with data structures, that's when it's useful. So we have one data structure or one method that handles multiple types. All right, and then we get to our useAllItems method. We're going to iterate over the inventory. Inventory is of type usable, so our only choice for type here is usable or object, if we just want to like print everything to the screen or something like that. But we're going to use usable here, which means from the item variable, we can call the use method, and that's really it, because that's what's in the usable interface. And then the object methods, we could toString, we could equals, we could do those things. We can always do those things. But the only extra thing from our code is the use method that takes a player. So let's call that method. It's the only thing we can do. And then our next question is the next big thing that you'll be assessed on in the quiz. Which method is called when this method is called? So usable is the variable type. The variable type decides whether this is a valid method call or not. Usable knows of the use method that takes a player. We call a use method. We give it a player. And this is the calling object, which is of type player. Everything's fine there. But then which method is called, that's up to inheritance. So polymorphism decided, is this a valid call? The quiz code, it's going to be valid. I mean, it's going to compile. But then which method is called? And this actually follows the same exact rules we did during inheritance week. This is what I mean when I say if you treat this as the inheritance quiz, you'll be fine, because polymorphism, all of it's going to compile. Polymorphism decides whether it's going to compile. Then when you're writing code, actually designing for polymorphism, that's where polymorphism really gets tricky and powerful. But the use method, which one is called? So item.use, item dot, follow the reference to the heap. Use, we're calling the use method. So this is going to be 480, the calling object. And the object type is weapon. Which method gets called always depends on the object type. It's of type weapon. We look in the weapon class. We find the use method. That's what's called. If we didn't find it, we would go to the superclass and look for a use method in the superclass. But we found it in this class, so this is the method that's called. For potion, we iterate to the next value in the array list. This dot use, that's of type potion. Look in the potion class, find the use method. That's the same thing we did during inheritance week. We're looking for the class that matches the type of the object. So even though these references are stored in type usable, it's going to go by the type of the object, not the type of the variable, to determine which method is called. And then even when we get back to the stack frame, we have weapon, OX480, item, store the same reference, OX480,